Hello and welcome. In this video, I will demonstrate how to configure EKS-Auto and Karpenter to make use of VPC's secondary IP address. In order to achieve this, you will have to configure custom VPC CNI configuration. Also, you have to configure a node class and node pool for Karpenter that will override the default node pool available as part of the EKS-Auto. All the configuration files discussed in this video are available at my blog site as well as on my GitHub repo. Check the comment section for the links. Kubernetes requires large pool of IP address for its own ports as well as all the nodes. This is not always feasible in many organizations. You may have a small network range that will allow you to deploy Kubernetes into. This is where the secondary IP is coming on. You can still deploy your nodes into the primary IP address, whereas the ports can be deployed using the secondary IP address. In this example, I have a /24 IP address for the primary network. So all my hosts will be using the IP address from the /24 subnet. And I'm defining a secondary subnet for 100 range, and that is /16. So that will be plenty of IP addresses for my ports. So I have already provisioned a VPC, and that is having a CIDR range of 10.0/24. And you can see there is only single CIDR range. And I have also provisioned 6 subnets. There are 3 for the private and 3 for public. If you look at the routing table, you will see there is a public subnet, and that is routing to Internet Gateway. And the private subnets, all of them are routing to NAT Gateway. I have also provisioned a EKS cluster. So this is a EKS cluster, that is EKS-Auto. There is nothing additional done. I just provisioned the EKS cluster, nothing more. Let's connect to the EKS cluster and see what is already provisioned. So I will configure the kubeconfig, and I'll launch the KNINS. So as you can see, there are no ports. If you look for nodes, there are 0 nodes. So this is a vanilla EKS-Auto with no other configuration. When you look at the node configuration and node class, you will see there is a default node class already provisioned by EKS-Auto. This node class is configured to use the subnet, that is private subnet. There's a default node pool as well. If you look at the configuration, you will see that this will provision on-demand instances. So with the default configuration, let's deploy an application and see what will happen. So here you can see EKS-Auto no nodes and 0 ports. So I'm going to run a pod. So here you can see the pod is created, but there are no nodes, so it is provisioning pending. If you look at describe it, you will see no nodes are available. So here Karpenter is provisioning a new node, and once the node is ready, the application will be deployed. So let's look at the configuration of the node. And when you look at it, it's taking a C6A large. So you can see the type is on demand. Let's look at the IP address. So the IP address is 10.0. So this is the private subnet IP address. So our pod is deployed now, and the pod also is using 10.0. So we are using the private subnet IP address by default. So here is the configuration. I'm creating a VPC using the module, and I'm specifying the private subnet, public subnet, and single NAT gateway. In terms of EKS-Auto, again, there is nothing special. I'm just configuring a EKS-Auto using the EKS module and providing a name, version, and I'm enabling the public endpoint access and this configuration for the enabling the EKS-Auto mode. So there is nothing about the secondary IP address in this one. This is a standard VPC configuration. So to get started with the secondary IP, first thing you need to do is attach secondary CIDR range to our existing VPC. You can do this within this module itself. I prefer to create it separately so that we can have a specific tags for the subnets. That will be useful when you create CNA configuration and node class configuration. I will define the variable secondary CIDR block and port subnet. So the secondary CIDR block will be in 100 range /16, and I'm creating three subnets of /19. So I'm creating a secondary association. That is the first thing. We create a secondary CIDR range association to your VPC. Then I'm creating a subnet for all three regions. I'm creating in EU West one, so I'm creating in three different regions. And then I'm creating a root table, and I'm associating it with the same existing root table where it will be using the NAT gateway. I will apply this configuration first. I have applied the configuration for creating the secondary CIDR range. Let's have a look at the configuration in the console. So we'll go back to our VPC. I select my VPC. You can see there's a VPC here. And if you click on it, you can see there are two CIDR ranges, that is 10.024 as 100/16. If you check these subnets and sort it by the name, you can see there are three public, three private, and there are additional three subnet that is on configured to use the CIDR range of 100. And if you look at the root table, and we are still routing towards the same NAT gateway. VPC is configured with secondary subnet range. So now we have to configure EKS. So on EKS, we need to install the AWS VPC CNI with some custom configuration. Here I am using Terraform to install the VPC CNI package, Helm package. You must enable the custom CNI networks and pod ENI and prefix delegation. By default, VPC CNI is installed with the EKS, and these are some of the defaults you need to override. Enabling subnet discovery is optional. You also need to create ENI configuration per subnet. So in this example, we have three subnets dedicated for the pod and all of them in 100 range. So I need to create a subnet ENI configuration for each of those subnets. For example, this one will be EU West 1A and the subnet ID of EU West 1A pod subnet. You also specify the security group to be used for this particular network. And in this case, I'm using the same security group as EKS cluster configured. I will apply this configuration now. I have applied the ENI configuration. So let's have a look at what is configured in the EKS cluster. So still there is no ports. If I go to ENI config, you will see there are three configuration files. This configuration file name must match that is of the subnet. So EUS 1A must correspond to subnet in EUS 1A. So if I describe, you will see it is causing the configured to use the subnet ID ending with 8100. And here you can see what 1A is configured for 8100. So this is all the configuration you need to do for the VPC CNI. Now we are ready to configure the Karpenter node class and node pool. If you look at the default node class, this is using a role. That role is kind of dynamic. We can make use of this role itself, or alternatively, I'm creating a new node role so that I can hard code this role name into the configuration. So I'm creating a node role called Amazon EKS-Auto node role, and I'm attaching two policies, Amazon EKS worker node minimal policy as well as container registry pull policy. You also need to create an access entry for this particular node role. If you're creating a new node role, you also have to define an access entry. So here I'm creating access entry type EC2 and associating that with the role I'm creating. If you look at the node class, you can see there is a security group attached to it. And this is the same net security group that was created as part of the EKS creation. You can make use of this particular security group, or you can define a custom security group. In my case, I'm also creating a custom security group called EKS-Auto secondary port security group. So this will be used only for the secondary subnets. I will apply this configuration. I have created a new node role and also created a new security group. Let's take a look in the AWS console. So here I have my EKS demo cluster. And if you look at the access control, you will see I created a new node access entry that is type EC2, and this is having a group system nodes and Amazon EKS Auto node policy. This is same as the default one created when we created EKS Auto. Now we are ready to configure our custom node pool. So here is my custom node pool configuration. I'm creating a new node class and calling it primary node class. These are standard configuration. And here in terms of role, I'm specifying the custom role I have created. We can either use this role or the default role created by the EKS cluster. In terms of security groups, I'm using the tags to identify the security group. So this is the security group for the primary private subnets. And there is another one for the security group selector for the secondary subnet. So here I have a specific tags assigned for each security group. You also need to specify the subnet selector. So subnet selector by default, this is the subnet selector for your private subnet, which will be used by your nodes when they provision, and subnets to be used for when we are provisioning the pods. We are also configuring the node pool, and we are calling it primary node pool and specifying a weight of 20. The default node pool is configured with weight of 0. Node pools are selected based on the weight. Highest number node pool will be processed first. So here I'm making sure this is higher than 0. That's it. And everything else is standard configuration. I'm provisioning spot instances or on demand and instance type and also AMD64 and Linux. Let's go ahead and apply this configuration. So here you can see only default node pool and node class. I'll configure the CNI node pool. And here you can see it is configuring and it is unknown state. We'll have to wait for it to be ready. So here it comes to a ready state. So if at all you have any problem with this node class, the best thing is to look at the do a describe and look at the status of different configuration. Here you can see subnets are ready, security groups are ready, instance profile ready. If any of those configurations are wrong, you will see a message here. Here you can see the node class. We have a node class called primary node class and the weight is 20. So now we are ready to test our new configuration. So let's look at the ports. So we have no ports and look at the nodes. There are no nodes or ports. So let's run a simple pod and see which IP addresses we'll get. So I'm running an engine export. You can see there is an engine export being created, but since there are no nodes to provision them on, it is still pending state. If you describe it, you will see the reason. No nodes are available to schedule the pods. This will trigger the Karpenter to pick up the job and provision a node. So here you can see Karpenter provision a node. While waiting for it to be ready, let's have a look at the details. So here you can see C6A large. So here you can see it is pod instance and also is using the primary node pool. So this clarifies that we are using this particular job is using the right node pool. And also if you look at the IP address, this is from the 10.0 range. So our pod is ready. And if you look at the pod IP range, is taken the secondary subnet range. So this is how you configure Karpenter to use the secondary IP addresses. Hope you find this information useful. Thank you.